Welcome to the Internet of Water peer-to-peer network webinar series. Today, we have a presentation about the Oak Ridges Moraine Groundwater Program and how it is using data to improve water management. So my name is Lucas Stevens. I'm a policy associate at the Nicholas Institute at Duke, and I will be your host for our Internet of Water webinar today. Today, our presentation comes to us from our neighbors to the north, from Ontario, where for the past 20 years, the Oak Ridges Moraine Groundwater Program has been collecting, managing, and sharing a wealth of water-related data and analysis, all for the purpose of improving land use and water decision-making across a 35,000 square kilometer region in Ontario. We'll hear from Steve Hollish, who manages the project and serves as senior hydrogeologist at Oak Ridges Moraine. He will walk us through the project's website, which is the access point for all of the data, and share his thoughts on data and resource management more broadly. So I'll hand it over to Steve in just a minute, but first I want to go over some housekeeping details. So we are recording the webinar today, and we'll make the recording and the presentation slides available on our website as soon as we can. So if you have to leave early for any reason, or if you want to share the presentation with your friends and colleagues, it will be available for you later to do so. Following the presentation, we'll have 15 to 20 minutes or so for Steve to answer your questions. And you can submit these at any time during the presentation or afterwards in the Q&A box. And I will read them out and moderate discussion at the end of the presentation. If you have any administrative issues, for example, if the audio or video isn't working, you can put these in the chat box and we'll try to get those fixed as soon as possible. All right, so thank you all for coming. Now I will turn it over to Steve for his presentation on how water-related data is being managed to improve decision-making in Ontario.
Anyway, thanks for that. It's a pleasure really to give this presentation through the Internet of Water. When I first came across the Internet of Water a while ago, I was surprised and pleased to see the synergies between the thinking in our program and the thinking and direction being proposed and taken through the Internet of Water. So I think at the end of the presentation, you'll see that there's a strong synergy between our two initiatives. And so I guess a goal of today's presentation, I thought maybe two goals. One is for our friends in the US and others who might be looking elsewhere. They can maybe take some elements of our program and build upon them and use them in different geographies across North America or elsewhere. And then secondly, for people around Ontario who might be listening or in our program area, maybe they'll learn a little bit more about the program and maybe how to use the website a little bit more effectively. So my first slide here is a little bit busy, but there's a couple of things I'd like to focus on while it's up. The first is up in the upper left. Just would like to give a shout out to my coworkers, Rick, Mike, Mason, Britt, and Steve, who have contributed to all the work that you're going to see in this presentation in many different ways. And then also one of our partner agencies, the Central Lake Ontario Conservation Authority, has also, their staff in the GIS and IT departments have contributed really significantly to getting our website up and running and maintained and whatnot. So hats off to all of them. Then on the bottom of the slide, you see all these logos. So we're a kind of a coalition of a number of local government agencies that have partnered together to try and better manage water resources, groundwater in particular, but in general, I mean, we'll get into a discussion more broadly on water. But the 5 senior governments there, York, Peel, Durham, Toronto, and Halton, are the main contributors financially to our program. And we obviously thank them really tremendously for supporting the program and continuing to work with us. And then the water management or conservation authorities in Ontario here are also partners to the program. And everyone contributes in many different ways to knowledge, insights, information, data, and whatnot to the program. And we also have links to the province of Ontario, the Ministry of the Environment, Ministry of Natural Resources, and the Ontario Geological Survey have all been, somewhat active and interested and partnered in the program in different ways over the years. And also the Geological Survey of Canada, we've worked with at the federal level in many different ways. Okay, so that all being said, now of course my slides won't go down. Come on. Page down, next page. Oh, for heaven's sake. Okay, there we go. So just for friends to the south in the United States, whereas Ontario, it's a big province, big part of Canada. You can see in red in the upper left there. We're only in our study area focused on a very small part of Ontario down in the south along the north shore of Lake Ontario. So even though it only, our study area only covers 3% of Ontario, it does hold some 50% of the population. So some 7-8 million people live in our study area, mostly along a sliver of land along the north shore of Lake Ontario. And you can see in the table up above there that, comparison of the study area to some smaller states in the US. You could see that, the study area is quite significant, even though it's a, quote, small area. And in the lower map, you can see the Oak Ridges Moraine outlined there in orange, and that's a topographic high. It's an interlobate cane moraine that provides the drainage divide between Lake Ontario to the south and water flowing to a series of lakes, the Kawartha Lakes and Lake Simcoe, and out into Georgian Bay eventually, which is part of Lake Huron. And then in purple is the Niagara Escarpment, which is a cliff face, a cuesta geological feature that runs through the Michigan Basin and extends into Wisconsin, Michigan, and in the United States as well. So that's where we're sitting, and this is the area we're going to talk about. So in Ontario, like most places in Canada, and I'm assuming it's similar in the United States, over the years, and in our case since about 1960, there's been many reports written by many different agencies on water management and how we can do a better job on water management. So these reports are written by federal departments, provincial ministries, local government agencies, non-government agencies, and so on. And there's many of these reports that you can find, and they're all available on our website in the library. But a common theme of all of these reports, when you look at them and read them, is that we as a society in general have to do a better job of managing water related data. And so from a groundwater point of view, this culminated in a study, a 2009 study. We were part of this, but prepared by the Council of Canadian Academies that looked at groundwater management in Ontario. It synthesized many of these earlier reports and provided some direction for going forward. We'll come back to this report in a sec. But really, it's surprising with all of this. Actually, one further report, just more recently, in the last year or so, the federal government is looking at creating a Canada Water Agency. So we can look forward to more papers of a similar nature to the ones I've just shown as we go forward. So it's surprising that given all the brainpower that's being put into all of these reports, and given the recurring call for better management of data, that really to date, not too much progress has been made. There has been some, but not a ton. So it's surprising that people just don't take a page out of Nike's book and just do it. And that's what we did. So when we started our program in 2001, we decided we'd focus on data and really just do it one step at a time. We're going to be opportunistic with collecting data into the database, but regardless of where it came from or how it ended up in the database, we would have kind of a home for it. And we took this really long-term vision of the program, more than 100 years. If you're going to invest time and energy in this, you really want it to last. So getting back to that 2009 report for a second, one of the main figures that came out of that report is this pyramid figure, and it really crystallizes how we've set up our program here in Ontario. And at the bottom, the foundation of the pyramid is obviously database management, and we've spent a lot of time, a lot of effort in putting together, what is now about 90 gigabyte database of information, all tied to water and geology, because we're hydrogeology focused in our program. And so once you have all that data together and managed properly, then you can start understanding the geology. In our case, we have glacial sediments laid down, and most of the groundwater is flowing through glacial sediments. So we have to understand how they were deposited, where the permeability changes are, and so on. Once you understand the geology, then you can look at how groundwater is moving through those different sediments. You can put all of that together in the next step through numerical groundwater modeling, which synthesize a lot of this information. And all of that science, hopefully at the top of the pyramid, will lead to better decision-making and improved land use. So that's kind of the backbone of how we've structured our program. And so if you take a step back, I'm sure many people have seen this kind of stuff before, but when we started our program, really what was happening in Ontario, and still largely happens even in our study area, that there's many consultants out doing lots and lots of work, drilling many wells, collecting geology samples, water levels, water chemistry, pumping tests, and so on. And that data is put into reports, and it's active and available and accessible only through the reports for a very short window of time, maybe 6 months or so when I was in Halton, one of the municipalities here. After that time period, when the land use approval is dealt with, the reports go down into the basement, into a warehouse, and then out off-site, and they're never used again. The reports are never seen, the data is never managed. And as a society, we spend all this time, all this effort and money getting data, and then we throw it out. So it was crazy. This has always driven me crazy. So we think we've been successful in our program. A couple of years ago, we tried to look at the value of how much money was maybe wrapped up in our program. And when you look at, all of this information here, we have 550,000 boreholes in the database. We have 116,000 water quality samples, many hundreds of millions of water level monitoring data, 12,000 documents in a library that I'll show you in a few minutes. Numerical modeling, we've taken all the numerical model files that have been produced in our geography and put them into a custodianship program. And so when you look at the value, we nearly have $1 billion of value that we've collected into the program over 20 years. And of course, as MasterCard knows, all of the information is priceless, really. And the figure on the bottom was one of my attempts to get funding for our program, shovel-ready infrastructure. But infrastructure in Canada and many places has to be hard infrastructure, pipes, roads, bridges. Data management doesn't count, unfortunately. So before I go to the website, what I wanted to do is just give you an idea of some of the significant elements or themes that run through our program that we think have made it successful. And there's a lot of words on these 2 slides. I'm going to show you 2 slides here. The talk's being videotaped, so you can come back and take a look at them later if you need. And then we're going to go to the website. So in no order in particular, we have a focus on data and data management. We have a standardized, well-designed data schema that allows for the incorporation of a wide variety of data sets. Anything related to water, whether it's precip, whether it's chloride concentration, whether it's a pumping rate, can have a home in our database. Second point is it's kind of a collective data management. You've seen all the logos there. So getting data and input and feedback from many different partnered agencies, companies. And what we're trying to do is develop a 2-way street where external parties can provide feedback and provide data to us. All of that gets put in the database, is continually interpreted, fixed, and so on, and leads to continual improvement, another theme of the program. We use the data. This is, I think, is important. So if you're going to house data, it's very difficult to tell whether data is good or bad, and if you can you trust it or not. And this is often a holdup to many water data management schemes, that people think, wow, we got to do the QA, QC. No one can see the data until we're sure it's perfect. We're taking the other approach. We've let it loose and made it accessible. But as we've done that, we've interpreted. So when we interpolate a water table surface or a geological layer or look at a hydrograph, the anomalies start to show up, really jump at you. And what we do is take a look at the anomalies, move a well, fix, it might be units, metric versus imperial. We fix the database all the time. We're constantly improving it. So if you come in and look at the database today, tomorrow it's going to be different. Important to use the data. So we provide access not only to raw data on the website, as you'll see, but also to interpretations. And we think that this makes a lot of sense. Why would everyone want to have to do their own water table mapping or their own geological mapping. If you can take what we have and maybe tweak it or alter it a little bit to meet your needs, but rather than everyone doing the same thing, we provide some interpretations of the data. We have a theme of knowledge management, thinking about future practitioners and how we would pass knowledge down to them. So that's another theme I'll come back to. All of the data, we have this interactive mapping tool that I'm going to show you in a few secs, and we think that's really important to the success of the program. We have this idea of living models. So all these numerical models that are in the program, people can check them out through the custodianship program that Mason runs. And if they make changes or improvements to the model, they would provide them back to us. We would make those updates and make the improved model accessible to the next consultant. We have this holistic approach to water as hydrogeologists. We're not only worried about how water moves through the ground, but we have to really pay attention to what's falling on the ground, how it moves through the ground, and then how it discharges and where it discharges to streams. And so we have this holistic approach to looking at these three aspects of the hydrologic cycle. Through our program, we think we foster communication between the different agencies. So, watershed authorities are talking to municipalities. There's a lot of interaction and people learn from each other, not repeating mistakes and so on. So we think that's valuable. And then this idea of long-term thinking that, again, was not driven by short-term political agendas to date, and we've been fairly lucky that way. So those are some central themes that you can keep in your head as we go through the website. Okay, so I'm going to flip over to the website now, and we'll go through there, and hopefully it's all going to work. I want to check the time. It's 1:20. Okay, so I'm not too bad. So when you land on our website, this is where you. So when you land on the website, this is what you see. And I'm just going to show a couple things here quickly. So we have a whole bunch of ORMG reports under here that may or may not help you, but we have an annual report we put out every year. Some of the early thinking about how we structured the program, because there's so many different agencies tied in the program. We had a lot of thinking in the early days, and that might be outdated now, but who does what and so on. Memorandum of understanding between the agencies is there, and some of the technical work we've done. Under support here, we have a database manual. If you want to know more about how we structured the database, Mike from our team has put together a really thorough database manual that you can have a look at on the website. And there's a bunch of other information that you could access if you want to snoop around. But where we're going to go is so we have two mapping windows. One is a sign-in window for partners. So we do charge a small fee to consultants to come in and access a lot of the information, but about 50–60% of it is available to the public if you click on maps. But anyway, I'm going to hit the sign-in page, and when you hit the sign-in page, this is where you land. We're revamping our website, so this might look a bit different in the next few months, but for now it's fine. So one of the first things I'll show you on the website is I mentioned these 12,000 documents, and you could go to the document search, and you could search documents a number of different ways. So author agency, if you want to, any consulting firms that are working in their area, you could find all of their reports. I mean, we had one consultant who donated all of his reports to us. He was getting close to retiring, and Brian has shared a whole bunch of his reports with us dating back to the 70s. And so they're all in the database, and you can look on author, search on author. All of these reports should come up really quickly. Oh, you know what? Actually, if there's people snooping around our website, it might make this a bit slower, which is unfortunate. But anyway, you can click on these reports, and this is a report from '84. Often these reports have maps and wells and water level and data in them. And I gotta hide this. Anyway, I won't hide it. So all of those reports are available. I'm not gonna see this. Let me do this. Oops. Sorry, bear with me for a sec. I have that Zoom meeting window at the top that I don't really want to see so much. Okay, there we go. Okay, so you can search through the documents a number of different ways. So 12,000 reports, all easy to access, keywords, consulting, company, and whatnot. So that's one part of the database. I'm not going to get into the monitoring data here, but if you wanted to fish out water quality data right now, this is our best interface, and we're looking at putting a new interface together for that. That will be up on the website hopefully this year. So I'm going to go to the maps icon now. And when you get to the maps window, this is a bit annoying. You see there's a whole bunch of different maps, and all the ones towards the bottom now we've wrapped up into this consolidated mapping. So the top 3 maps are the ones that I'm going to focus on today. So if I hit this consolidated mapping window, it goes off, and you have to just hit a quick disclaimer that just says, we're not responsible if the data is wrong, and use it wisely and so on. So once you land on the website, so this is a program called GeoCortex. It was recently, I think it was a Canadian company that got bought out by Esri. So it's part of the Esri group of GIS products now. So once you land here, there's a welcome window, but I'm going to click on the layers button. And when you do that, you're basically ready to go. And so if I jump, since I just mentioned documents, I can go to the documents window. So these are different theme maps, and these maps are what you saw in the last window when I scrolled down. And what we've tried to do is organize all the information in the database into themes that make sense. And you can mix and match through this layer catalog anything that you see on any map. But for now, we'll just go at them one at a time, a few of them. I'm not going to have time to show you everything here. And I will point out too that if anyone on the webinar wants a password temporarily to snoop around on the website, you just send an email and we can make that happen pretty easily. So don't hesitate. So if I click on any of these, all of documents, 12,000, we'll put XY coordinates on them. So they're easy to find on a map, which makes it amazing. So if I click on any dot, I can go through, I got 8 different reports there. I can click on any one of them and get back to that window and open up the report. So really a really nice way to fish for information through a mapping window. And we have filter tools. So if I wanted to filter those, we have a nice our database guy Mike has put together a nice bibliography view. So if I put the same Whitehead, AD as the author, there's all the reports that company rural development consultants provided to us, and there's where they did all their work over the 70s, 80s, and 90s. So again, those reports are very easy to find. Okay, so that's the documents, and that's an idea for those of you out there that consulting reports are often missed. People focus on government data, they focus on academic data, but often they miss consultant data. And given that all of the consultants are trained, there's a lot of good information in these reports. And slowly over time, when you click on the reports, like I said, we hire students in the summer. When you open the reports, you go to the back, you get all the water chemistry and boreholes, and we slowly move all of that information into our database. Okay, so I'm going to close the filter tool. One of the other maps that I'll take you to is the location map. So this is where we landed when we first came in. And what we defaulted to come on here is these groundwater knowledge insight locations. So I mentioned that as one of the common themes in our program. And so if I you can zoom in on the map, obviously, but if I click on, I think it's this one here. I mean, all of these reports, basically, that's not the one I wanted, but all of these reports generally, what we've done is put a memo field in one of our tables in our database, and we've allowed a short story to be written about any of these locations. And typically they're locations that you want to be careful with. So flowing conditions, really coarse grained aquifers close to surface, maybe water quality issues. We haven't really focused on contaminated sites in our program because there's a lot of sensitivity with property values and so on. So we've largely focused on clean issues or road salting issues and so on. But if someone was starting their career, say in 2050, and you could give them an idea of where the areas are that they should be careful if they're going to do any subsurface work, because groundwater is, hidden below our feet. We're not often aware of it. But if you're going to drill or do some excavations, infrastructure work, first thing to do is come to the map. And the way we get these stories, we interview consultants and people from partner agencies that have experience. Often they're retiring and taking all that wisdom out the door with them. And so we try to capture that and put it on a map. You see other locations on the location map. We have surface water gauge stations, climate stations, permit to take water, oil and gas wells. So a whole bunch of information all related to either subsurface or water is captured in the database. And when you click on any of these points, you can get more information and view additional details and so on. So really nice and easy to get information. Okay, so let's jump away from the location map. I wanted to take you to the water table map. So this is one of the interpolated surfaces that we've put together. So you land here and you've got a number of options on the legend. So we have the water table map opened. If I start zooming in, I think the contours should show up. If not, I'll turn them on. Yeah, so you can see it's contoured. All of these layers have sliders on them, so you can see you can slide the transparency to see what's behind it. You zoom in far enough and all the data comes on. So the water table itself is constructed from wells that are only 20 meters deep or less, where the screen. So we have a real focus too on 3 dimensions in our database. So every water level in the subsurface is tied to a screen, not to a XY, but to an X, Y, and Z. And that's really important from a groundwater point of view. So here's all the wells that have been used to create that surface. You can click on any of those wells and you can open up the original water well record right from the database. This goes to the Ministry of the Environment's website. And this is a well drilled in 1963 that has been used to construct that surface. So the other neat thing about the water table, so water table, groundwater is flowing perpendicular to these contours, but the other maybe more interesting map we've done is how deep is the water table. So you can turn that off and turn on the depth water table. And this tells you how far below the ground surface water table is. So we're at 130. I just got to keep an eye on time because there's a few things I want to show you here. And one of the things in working with, so you see up on the Oak Ridges moraine, the water table is quite deep. It's a sandy, gravelly moraine, and the water table can be up to 50, 75 meters below ground surface, as opposed to when you move off the moraine towards a lake, very close to ground surface, 0, 5 meters, and so on. And recently working with the city of Toronto, what we've done, actually I'll leave that on and open up the legend. Where you have a plus sign on, all these legends can be opened up and looked at further. But the city of Toronto is looking at, with climate change, and given their storm sewers and sanitary sewers are all largely working at capacity right now, what they are interested in is trying to get developers to move big towers with deep parking garages to areas where the water table might be deeper. So what we've done is parse the depth water table map into different chunks. So if you want to see areas where the water table is deeper than 10 meters, you can turn on this layer. Conversely, if you want to see where is the water table really shallow, 1 meter below ground surface, again you can play around with all this. You can print from any of these maps. So you can, all our consultants have their logos up here. They can print with their logo on and so on, and all the agencies as well. So that's a water table map that's, we think is a really valuable piece. As hydrogeologists, we come to the water, the water table with this view of a more holistic view of water than just looking at the surface water flows. However, we do have a surface water map here. And Mason is our modeler and our hydrologist in our team. And he's put together a lot of these products and statistics that I'll show you in a few minutes. But one of the things on the surface water map is you can delineate the drainage area. If I click on any one point on a stream, it delineates the drainage area to that point, gives you the area, which is helpful if you're doing hydrology studies. You can also similarly, if I click on another part of the river, oops, actually I want to click on right click, left click does different things here. So I can see the downstream or upstream flow paths from the stream. So there's all the drainage area that's flowing to that point, or downstream it shows me where that's flowing down into Lake Ontario. So a number of different features on our surface water map. Another interesting thing we've done with all those models that we have, we've started to show the discharge that the numerical models say is occurring or happening or moving out from the groundwater system to the surface water system. Here in Ontario, that groundwater discharge is really important from a cold water fisheries habitat perspective. Brook trout and other species that are sensitive and need cold water. People want to, as land use changes and development applications come in, you want to see where the groundwater is discharging. So if I turn off the streams, you'll see that some of the streams disappear, and these blue pieces are areas where the numerical modeling, so that's a synthesis of all the land use, the geology, the precip, the stream flows, where the models indicate groundwater is discharging. And we have another tool that's coming in the next little while that'll take some of the spot flow data. So the conservation authorities or watershed management boards, they go out and measure spot flows now and again. And we have another tool that will look at the pickup between different locations on the same stream network. So that's the surface water map, give you a flavor of that. I'll take you to the boreholes quickly. I know that a lot of people are maybe not so focused on geology, so I won't spend so much time here, but we have the wells. You can filter the wells in many different ways. You could filter them for depth. You could filter for sand and gravel thickness, many different ways on the fly, but we have them grouped into categories here. What we're showing are all the wells that are flowing. So this is, this map really shows you where you must be careful if you're going to do any subsurface drilling or works in our geography. One of the things we've recently started doing is putting up these boreholes with supplementary logs. So in addition to the reports that I've shown you, if I click on any of these pink dots, what you can do is open up this. So this well has no record in the provincial data set, but if I open up the non-MOE, MECP, the Ministry of Environment just changed their name. So I can open up a consultant borehole log, so this log has no record in the provincial data set, but it was in a Gartnerly consulting report. And so we brought these PDF records onto the website. And there's many old, really deep wells that are important in terms of understanding the groundwater flow system that are up on the website. Okay, so I think, what's my time? 1:37. Okay, I'm going to show you quickly another tool, this cross-section tool, and then I want to wind up with looking at statistics quickly. So one of the things and this is a tool that maybe again other people can use. I think we got the original code from the Illinois Geological Survey and we built on it, but it's a different map than the other map. But you come to this map and you can just take the line and draw a cross-section anywhere in our geography, double click to end. And I can open up a regional, in this case, I'm going to open up a regional cross-section. Just takes a few seconds. So we've done thousands of cross-sections. This is work that was started by the Geological Survey of Canada a number of years ago. And we built on it and developed it. And you can see all the glacial units down to bedrock. You can change the vertical exaggeration on the fly 15 times to emphasize different aspects of the geology. All the wells are available. You can click on the wells, get the water well record, and so on. And you can also, if I close this, most people aren't doing regional sections, but local sections. So, if you just were looking at at a site, you could get a small cross section, see how deep the water table is, how deep the bedrock is, and so on. And we also have a virtual borehole here that if I want to see what would the geology look like if I was to drill here, well, bedrock's pretty close to the surface there, so I should go maybe up on the Moraine and do the same thing, and you'll see different geology. So that's a virtual borehole tool that drillers or anyone doing investigations can come to and make use of. Okay, so that's the cross-section tool. Now, the other place I want to take you is and this is again, most of Mason's work. So he's put a whole mess of statistics up onto our website. You can access it through the geocortex map that I showed you earlier, or you can access the statistics through Mason's Shiny map. And these are tools that you've heard in different Internet of Water talks. We're using Shiny, Leaflet, R for all the statistics, similar to many other agencies out there. And if you want more information on this, I can link you up with Mason for sure. So what Mason is showing here is we have a tool that lets you see what date range you want to find data in. So right on the map, you can start filtering. If you want to see wells that have data in the past, you can do that. We'll leave it up here. I can turn on climate stations and stream flow stations on the same map. I'm just going to zoom in anywhere. I'm going to just do this randomly and hopefully things will work. So I'm going to click on one stream flow location in blue, and I can go to that location and get all the data. So Mason's tool goes out and grabs the data, puts it up on a hydrograph here. You can see the rainfall and snowmelt. So Mason's done a long-term climate interpolation to every point in our geography. You can get a 100-year climate record interpolated through a Delft Fuse climate system that Mason can talk to in more detail. But you can see precip, how the stream responds to precip. You can zoom in on different parts of the hydrograph if you want. And you see the graphs at the bottom change as the duration curves and the monthly discharge. There's a whole bunch of, you can do base flow separation on the fly up here. So taking a look at, if I zoom in on an area, there's 14 different methods that Mason has put in here. And the green shading shows the max and min of those 14 methods. You could show each one individually. It takes a bit more time. But a lot of information here. You can download all the data. There's disaggregation. There's a whole download data there. A couple of the things that I'll maybe show you is you can take a look at the base flow versus the total flow of all these 165 different stations in our geography. 142. Okay, I'm gonna have to wrap up soon, so I'm not gonna belabor this, but all sorts of statistical tools that you can fiddle around with there. And the same thing if I go to a climate station, similar kind of analysis that you would get with climate, different kinds of graphs. You can look at seasonal trends. So what we found in Ontario is sometimes the climate is changing and you can look at precip, snowfall, temperature if it's available. This station doesn't have temperature, but you can look at winter, spring, summer, fall on all of these hydrographs. All of these windows are opening. I can't see them to close them. And then finally on the groundwater side, let me pick that one. So some of these have a lot of data. They go back into the 70s and it takes a couple seconds to load up, not too bad. The website itself is updated every week. So if the database changes today, on the weekend, all the tables that speak to the database are updated on a weekly basis every Saturday night. So changes made today would be reflected on the website next Monday. Okay, this shouldn't take too long. Here we go. So for for groundwater, what we've started to do is take a look at again, seasonal trends. I'm going to show you a couple. Some of the things we're looking at for groundwater is the variability. So these are plots that look at each year and where the highs and lows are in the groundwater system. Are the highs always happening in the spring with the snowmelt and the runoff, or do they happen in the fall? They're the lows always in the summer. So every one of our 300 monitoring locations, you can get all these statistics. You can look at the monthly distribution, how it changes, how the water level changes every month. So there's a lot of information up on the website related to stream flows, climate, and groundwater levels. And so that's kind of a whirlwind tour. The last thing I want to show you is something we're doing just recently. And again, this is something Mason's put together, but these are leaflet maps, Mason says, and they're really dynamic snapshots taken at one time from our database. And they're kind of nice products that you can put out and release to your clients or to anyone interested in your data. And really you can make them full screen maps. So this is linked to the database, gives you information on each station. This is just a base flow separation routine on all of our stream flow stations. And you can play around, this is a dynamic map, but it's easy to distribute to people wanting information that don't want to come into the website necessarily to take a look. And we have a few of these. We're going to be building more of these. The numerical models that I mentioned are all here, a little description, but again, interactive map where you can click on any one of those numerical models, get information, get a link to the report. And this map is, you can email this to someone. It's separate from the database itself. So it's kind of a nice product that we've just put together. And I have one on variability if I could find it, but is that it? Yeah, groundwater variability. Here's another one. So again, this idea of how much is the water table going up and down, and how often does it intersect with the ground, and in different places, what kind of what is the variability? Is it meter, half meter, 2 meters or more? And this map is showing, that variability across our whole geography. And again, so these dynamic data snapshots are a way that we're moving forward, and others might want to build on that. So I think with that, I'm going to stop. It's 1:46. I could show you tons more, but you get a flavor of what we've tried to do. It's really a comprehensive water management geology website. There's lots of tools in here, lots of data, and I've presented some of the key elements that we think have driven our program to be successful. And if you want to get more information or ask any questions, I'll stop there and leave it open to questions now. So I'll turn it back to you.
Thank you so much, Steve. That was really impressive. There's so much data in there, and it's so well linked, I found, with all of the visualizations and all the analysis tools that you presented. The sort of the linkages between all of the data was really impressive. So thank you so much for showing that to us.
Yeah, you're welcome. Thanks.
So I don't see any questions coming in yet. So feel free to put your questions in the Q&A box, and I'll read them out for Steve. But while we wait for questions from the audience, so you said something about that I thought was really interesting about long-term thinking. That this program can be guided by long-term thinking, and that sort of enables you to do certain things. Can you say a little bit more about that, and also can you relate that to how that's affected by funding, and whether long-term funding is really important for that? I mean, you said you charge a fee to consultants to access some of the database.
Right.
Where else does your funding come from?
Yeah. The funding largely comes from York, Peel, Durham, Toronto, and now Halton. Halton just joined our program recently. So they, on an annual basis, have in their budgets a line item for our program. And really, we report pretty high up to the commissioners, like the commissioners of public works and planning at all of those agencies. We circulate our annual report to them, and we have, periodic meetings. In the beginning in 2001 to 2007-8, we had, 2 meetings a year, 1 meeting a year with them. Now it's, as they see the program has evolved, they largely have confidence that what we're doing is in a good direction. But in the early days, before we had the website, we would show them maps at these meetings and say, yeah, things are moving forward. We had good communication skills. Both my coworker Rick and myself, I think, can convey complex ideas to these people, but really it was a lot of dancing around in the early days, and thank goodness they stuck with us. And now what we're trying to do is by linking with consultants, we want to get people to make use of all this information. We still think it's underutilized, to tell you the honest truth. And we think that the more people use it, the more that they'll, that it'll be hopefully impossible to break or not fund. So I mean, I think in some ways, like it's a tough issue to get long-term funding. We don't have long-term funding necessarily. I mean, if they decided, any of the partners decided not to fund the program, we'd lose funding. I mean, unless we went to the province, and the province hasn't really shown an interest in funding the program yet. I mean, they're more afraid, I think, of liability and so on. So making all those reports accessible, people go right away to the worst case scenario. Someone's going to make a mistake based on our data, and it's going to cost money.
Right.
That might be the case at the end of the day. I don't know, but I mean, for heaven's sake, of all the positives, my dad always said focus on the positives. So I try to find the focus on the good stuff that we're doing and the positive decisions that can be made by making all of this information accessible. But yeah, certainly long-term thinking is needed to invest in this, right? I mean, I've been investing 20 years, and I got to find a way to make sure that it's going to carry on before I step down.
All right, so we had a question about putting a dollar value on the data that you store.
Yeah.
Can you explain a bit more about how you estimated that?
Yeah, I mean, I could go back to the slide, but you can see it if you take a look. But what I did is I said, okay, how much, if we were going to replace all of those wells in the database, how much would it cost to drill them? So that's a lot of value. 12,000 consulting reports. I said, okay, let's estimate each report is whatever, 10, 20,000. I can't remember the numbers on the slide, and multiply it out. And, if you have 100 million water levels, so I said, okay, how many would you, and I focused just on the manual water levels. So if you visited 4 locations 5 times a year and got these water levels, how many field days would that be for a consultant? So, and the numerical models, they're some of them are, $3 million studies, others are $50,000 studies. So I put an average number on them. So people can question the numbers up and down, and they're not fixed. They're trying to get a thumbnail value of what it would cost to replace what we've put together. For better, for worse. I thought it's proven useful. I mean, people, I wanted that number to talk to decision makers, politicians, and so on, to say, look, we spent 20 years as a society putting this together. Certainly there's value in here, and let's keep pushing it along.
Yeah. All right, we had a specific question about how stream discharge is calculated and brought into the data set.
So the stream discharge, we have I mean, one of the things I didn't point out, and Mason's done a tremendous job on this, but he has a scraper tool that takes data from Environment Canada's website, both climate data and stream flow data. So those are from Environment Canada, and tribute and thank you to them. So that data goes into the database. Once it's QA'd by Environment Canada, it's reissued, and as it's reissued, our website takes the qualified or reviewed data. So it's all put in there, but it's actually measured data from a program. It's a provincial federal HIDAT program that measures stream flows in a number of stations. And, you know, there's a whole bunch of tools in terms of base flow separation. We have, you know, there's information on the website, and we're putting metadata and information on on methodologies up onto the website, you know, every day. So technical data and details like that, you can contact me and we can show you that. One of the interesting dynamic data things I didn't show you is climate data count. We'll have this with streamflow data too, but this goes back to the 1840s. How many climate stations were actively monitored in our geography? And it increased in the 1950s, 1960s, and then decreased significantly. We brought in a number of stations from some of the partner agencies in here, so it went up. But right now it's gone down. We're nearly equivalent to where we were in climate monitoring here around the 1950s. So, you know, these are kind of interesting snapshots. We want to put a bunch of these together on you know, just to showcase different aspects of water management. We'll have one with stream flows in there and probably groundwater monitoring wells as well. Also budgets. I want to put in some graphics on how much funding we've given to, you know, ministries of environment, natural resources, and so on. Because I think this, as a society, we probably don't recognize how underfunding we are to some of those ministries that deal with natural resources.
Okay, we had another question about storage. Can you tell us a little bit more about how all of this data is stored?
It's not on the cloud right now. We have a couple of servers hosted at one of our partner agencies. And, you know, Mike, our database guy, is an IT fellow, and Rod, another guy at Central Lake Ontario Conservation Authority, do a tremendous job for us on managing the servers. And keeping everything accessible and running smooth. And it's, you know, they've optimized the website really, really nicely so that it's fast. I mean, you're looking through 90 gigabytes of data here, and, you know, yeah, water levels and climate data that goes back 100 years comes up really instantly. So I'm not the IT guy, but I mean, again, if anyone wants to contact anyone on our team, you know, the offers out there to learn and build on what we've done, for sure.
And then we had a question about, so our poll is popping up right now, our post-webinar survey. If you could just fill that out for us, attendees, that would be great. We have one more question while you're filling that out. Steve, if you could tell us more about challenges you had integrating data from different sources. What was that process like? And are there specific tools that you can recommend that you found helpful?
Yeah, I think the biggest integration was with the geology and the different kinds of well records, having to kind of pull that back to a uniform methodology in terms of describing, you know, geologic units and stuff. But in terms of you know, chemistry, for example, you know, lead versus PB versus, you know, all these different ways that parameters come in from laboratories, or water level readings. I mean, just, yeah, different, yeah. So we have a table, a couple tables in the database, the reading name code tables and alias tables that again, Mike has designed to if the data comes in with a certain name, it looks to all the aliases and assigns it our standard preferred nomenclature as the reading name code. And so there's, you know, the temporal data tables that hold all that data. There's really two different structured tables. One has two tables to deal with lab and sample integration, and the second table just has, you know, date, location, units, reading name code, which could be precip, chloride, whatever it is, and then the value. So really long table, 5 main columns that go 100 miles deep. And And as long as you're really paying attention to the aliases and the reading name codes and have a structure for that, it's worked out okay. I mean, yeah, there's been headaches though, but it's all, yeah, we haven't used external sources for that. We've kind of built internally.
Okay, and then the last one we have here is about a comment you made about data systems as an infrastructure. And if you have any tips on how to communicate that as a concept to people who are higher up who may be deciding on budgets and things like that.
You can use my my backhoe picture with data going into the ground. Yeah, no, I wasn't successful. I mean, really, there was a huge infrastructure funding program here a number of years ago, and I mean, I didn't maybe try as hard as I should have, but I honestly, I thought that our program should be funded under infrastructure. But yeah, I wish I had more insight to give you on that, but I haven't really had any feedback. Often you go to these infrastructure funding programs and the first thing you see is that data and digital infrastructure doesn't count. So it's unfortunate. Like they strike it right off the opportunity sheet before you get started.
Yeah, it's too bad.
Yeah, but I have, in my list of the many things to do is to go and talk to Infrastructure Ontario and see if I could get them interested. But yeah, you need connections and blah blah blah, and COVID is it, and so there's so much other stuff to do anyway. But I think it's a right idea. I mean, if other people can grab can grab that idea and move it forward and come back and tell me how you do.
Well, that is certainly what we're trying to do here at the Untitled
exactly.
Waters. Yeah, all about data infrastructure and
exactly. Yeah.
Promote it. Yeah. All right. Well, I want to say thank you so much, Steve, for that presentation. That was great, and thank you for everyone for coming and participating and for your interesting questions. My constant reminder, if you have not yet joined the Internet of Water peer-to-peer network, do so. We have conversations like this every month, you'll also get access to our newsletter and our infrequent reminders and announcements as well from our coalition. So please join, and thank you again, and thank you again to Steve. Any last parting thoughts? Anything? Any last parting thoughts from you, Steve?
No, just carry on. Everyone listening in, hopefully, take up the charge, and there's lots of work to do in this field. It's a tough issue to manage water. Too many people collecting it and not enough integration. So hats off to Internet of Water for leading a charge like this.
Yeah, and hats off to you. You're doing great work in Ontario on this. All right. Well, thank you, everybody, and have a good rest of your day.
Thanks so much.